Hello everyone, welcome to section 3 of Python for data engineering. And this section is going to be a little advanced because I'll be talking about some of the advanced concepts of Python. And it's not that I'll be covering a lot, but at least a few things that I'm covering, those are needed for data engineering also. Because if you want to write program using various libraries, these concepts would be needed. This is going to be the agenda. I'll start with object-oriented programming, wherein I'll go a little deep into classes and objects. Then I'll talk about modules and packages and how we can use the import command to import various modules and packages and libraries. Then I'll talk about namespace. There won't be too much of hands-on on namespace because it is basically conceptual stuff. And then I will talk about error handling, how we can handle errors in Python. So let's start with object-oriented programming. I have already told you about class and objects at a very high level. So what is a class? Class is basically a template or a blueprint to create objects. And objects are essentially the variables of class. So whenever we define an object, we are defining a variable of that particular class. For example, when we defined variable like order id equal to 1 2 3 4 5, and when I use the type command to print the data type of that particular variable, which is order id, it was showing as object of class int, meaning that that particular variable was an object for the class int. Similarly, we can create our own class, and whenever we create a variable or initialize a variable using that class, we are creating objects of that particular class. And class itself, by the way, is an object of class. So as I told you earlier also, that in Python everything is object. So whatever class we create, that is also an object of class. And as I already mentioned, everything in Python is object. So when I define order id equal to 1 2 3 4 5, order id variable is an object of int class. Similarly, when I define order price equal to 345.50, order price is an object of float class. And order description, which is a string, it is an object of string class. And when we define a class, the class also uses some amount of memory while executing. And the way we define class is like this. Instead of def, we use the class keyword followed by the name of the class. So in this case, I am defining the orders class as it starts with the class keyword, and orders is the name of this particular class. And inside of it, I have defined order ID, order price. I have defined functions also. So if you see, I'm using the def keyword, which is used to define functions. But when you define a function inside of a class, we call it as method. So here we have two methods, or I have defined two methods. One is calculate order price. This is a method which takes amount and discount as arguments. Then I have defined get customer details method, which takes customer ID as an argument. And you already know what arguments are. We can pass arguments to functions, and as functions are called as methods in class, so that's why you can pass arguments to methods also. Of course, there are a few other things that I'll discuss in the coming slides, but as of now, this is what it is. So all this order ID, order price variable, and the methods like calculate order price, get customer details method, these are called members of a class. So the variables that we define, the methods that we define inside of a class, those are called members of that particular class. So in this case, order ID, order price, calculate order price, and get customer details, all these four are members of the class orders. Now, the actual action that we take on class is after creating objects. And objects is an instance of a class. What I mean by that is, different objects store different values in memory using the same template. So in a class, we define the template or the blueprint, right? We do not use the class directly. We create objects using that particular class, which means that we create objects using the blueprint or template that is defined by the class. And we can create multiple objects using the same class. And each object will have different values, and they'll use the same template. So let's say in the template I have mentioned a variable called name. I can create multiple objects. So in the class I have just defined a variable name, and I can create multiple objects. Let's say name1, name2, etc. In name1 I'm passing Python, and name2 I'm passing Java. So what would happen is all these are different objects of the same class. For example, when I create order ID with 1 2 3 4 5, I can create order ID with 1100 also. Then I create order ID with 2200, order ID with 3300. Now all these are different instances of the same int class. Why they are different instances? Because they are holding different values in memory. But the template is same, which is int class. And objects can use the functions or methods defined in the class. So in string and set and tuples, I have shown you using multiple ways to add variables, get a substring, capitalize a certain string. All these are actually methods of the string class. These functions are defined inside of the class, and once we create the object, we can use those methods or functions defined in the class. So let's say I have this class orders. Here order ID, order price are the variables, calculate order price and get customer details are the methods. All these are members of the class. Now what would happen, how it would play out in memory? So let's say this is the RAM, and we'll have the class orders itself taking some amount of memory, not too much, because it has to store the definition. So the definition or the template has to be stored somewhere. That's why the program memory, this is the RAM which is being used by this particular program, and some amount of memory would be taken by the class itself. And this is how we create an object of orders class. So orders, open bracket, close bracket. So order 1 is an instance of order class. So order 1 is an object, order 2 is another object or another instance of orders class, order 3 is another instance of order class, order 4 is same, another instance of order class. Of course, I have not shown you passing variables here. We'll discuss that shortly, but let's make the concepts clear first. Now what would happen is that all these order 1, order 2, order 3, order 4 would be created in memory with its own value. So order 1 will have its own value, order 2 will have its own value, order 3 and order 4 will have its own value, but all of them will use the same template that was defined using the class orders. Meaning order ID would be there for all the orders, order price would also be there for all the orders. All the orders can use calculate order price method, and all the orders can use get customer details method or function. So again, imagine that we are creating a string, right? So if you create a string or multiple variables of type string, so all of them are instance of the same string class, but the values are different. Let's say in the variable 1 we pass Python, in variable 2 we pass Java. Both the variables can use the function capitalize or substring or lower or upper. Both of them can use it, but they have been created from the same class, which is str, but with different values. So that's why those are called different instances of the same class. And here order underscore 1 2 3 and 4, these are the 4 instances of the orders class. Okay, so let me show you this. And I have been using 3IAM Python basics. Let me go ahead and create a new Python file, and I'll name it as 3IAM underscore Python underscore advanced. So this is a Python file, and now what I'll do is I'll define a class. Let's say the name of the class is 3IAM, and I define some function here. It has to be, it cannot start with number, it has to be 3 underscore IAM. So let's say define a function find technology, meaning what are the technologies that 3IAM teaches on, and we define a function here named find underscore technology, and I have mentioned pass. There's something called self. I'll talk about self shortly, but I have created this class and it does not have anything, right? So I use a variable and name of the variable is 3IAM underscore training. This is the name of the variable. Now what will I do? I will create two objects using the same class 3IAM. So let's say student1, and I'll use 3IAM. This is the first instance. Then I have student, then I'll create students2. It will also use 3IAM class. Now if I type student1 and then followed by dot, see, I can use the name student1 dot name, and I can also use the find technology for student1. Now of course there's nothing here, but what I'm trying to say here is that let me now use student2 dot, I can use name and I can use the find technology for student2 also. So I can select this. Now what it is doing is basically, obviously it is not doing anything, find technology does not do anything, but if I print this name, it will show as 3IAM. Same is the case with student1 also. I can use the same variable for student1 and the same variable for student2. So what it means is that student1 is an instance of the class 3IAM. Student2 is also an instance of the class 3IAM. Right, again, I have not defined any variable, I have not defined any function, but this is how we create a class and this is how we create objects of the class. Now what will I do before executing this? Let me mention the type of student1 and similarly the type of student2. Right, and here I'll define one more variable named var underscore str, and the name is, let's say, technology, the value is technology rather, and I'll print the type of var underscore string. Now let's execute this. So what it should do is, so it would create an object of 3IAM class, and if I print to student1 dot name, then 3IAM underscore training should be printed, and then it will execute this function which does not do anything. Then I am printing the type student1, and the type student1 should be of type 3IAM, and this type student2 would also be the same. Now why am I printing the type of var string? Because I want to show you that how similar these are, because var string would be a object of class str, right? So now if I execute this, as you can see, first it is printing 3IAM underscore training. Then when I print the type of student1, it is of class something main, and then 3IAM. I'll talk about main later on, but essentially it is showing that it is an object of class 3IAM. Same is the case with student2 also, which is the object of class 3IAM. Now forget about this main for a moment. What it says, it is basically the type of student1 is class 3IAM, and the type of student2 is also class 3IAM, which is similar to type of variable var underscore str, which is class string or class str, which is similar to this. So this is what class is, and this is how we create objects of a class, which are nothing but instances of that particular class. Now let's go a little further and talk about what this self is, what these instances are, etc. So the next one is self, and it is very important for objects. And I would request you to pay a little bit more attention here, because everything lies around this, the self variable. Now when I defined this particular variable, so self was taken automatically. Now the question is, what is this? Okay, so you already know that object is instance of a class. So we define a class and we define the template. By template, by now you know that we define variables and methods or functions, and all the objects can use the variables and the functions of the class. Now this is the definition of the class customers, and I have added three methods here, or three functions here. The first one is underscore init. It is to initialize the class, or initialize the object rather. Then I have calculate order price. Then I have get customer discount. All these are three different functions or methods. But in all the places, I have to mention self along with the argument that I want to pass. Don't worry about init right now, we'll talk about init later on. But what am I doing here? I'm passing arguments. As you can see here, I'm passing the ID, here I'm passing the amount, here I'm passing the customer underscore ID. All these are arguments which are basically same as that of functions. So in functions also we pass arguments. Here also, because these are functions, we can pass arguments to these. But along with it, we pass something called self. So what is this self keyword? Again, I'll take you to memory, because without understanding the memory architecture, it will be difficult for you to comprehend how and why self is used. Okay, so this is the class and it will take certain amount of memory. Now, let's say I create two objects, cust underscore 1 and cust underscore 2, which are the two different instances of the same class customers. So cust underscore 2 is using customers class, and cust underscore 2 is also using customers class. So these are the two objects of the same class. Now the moment we create these two objects, you know that these two objects can use these methods that we have defined. Now what would happen is, it would create the customer 1 variable, and as it is an object, this object would be defined in memory, and as it is a variable, it will point to the memory address where this object is being stored, just like the variable that we had seen. Similarly, when I define cust2, it would be created in memory and it would hold the memory address where the second object is created. So let me first show you this. So what I've done here is that I've defined two methods or two functions. One is init and the other one is calculate discount, and self is coming automatically. You might have seen when I was typing that self was populated automatically. Apart from self, I had added this particular argument in calculate discount. Now what will I do? I will create two customers using the same customers class. So in this case, what would happen is that all these two would be the objects of the same class. Now, how do you print the memory location? So print ID customer underscore 1 and print ID cust underscore 2. So what are these? So as you can see, these are storing the memory locations, right? Let me comment these. So in the second one, now if I execute, these are two different memory locations. So cust1 is pointing to a memory location where the customer objects is there. So again, it is similar to defining, let's say, another variable cust underscore ID, and let's say the customer ID is 1100. What is cust underscore ID? It is nothing but a pointer to the memory address where 1100 is stored. We are passing the value 1100 to integer class here, but in the other two cases I'm not passing any value. That is the difference. And because these are internal classes, we do not have to define it on initialize it like I have done customer underscore 1 and customer underscore 2. But essentially all these three are pointers to the memory location where the object is stored. So cust ID, which stores 1100, but cust ID contains the address where 1100 is stored. Similarly, cust underscore 1 store the address where the first customer's object is stored. Cust 2 also stores the memory address where the second customer's object is stored. These are empty objects. It does not have any value because we have not done anything with the objects yet. But that is not the purpose here. I hope you understand what it is doing. So cust underscore 1 variable points to the object in memory, so it contains the address of that particular memory location. Cust underscore 2 variable also points to the customer's object in memory, so it contains the address location, a value of the address location. So these two are objects. Now what self is? So these two are basically objects of class customers, and we have already set that stage that these two are objects of the class customers. Now the moment we, let's say, use this method of the class calculate order price, and I am passing this argument 100. This 100 would go to amount, which you already know. But what about self? Self would actually get the address of cust_1, which is DE2. Similarly, when I use the method calculate order price with amount 275, this 275 will go to the amount, but self would contain the address of cust_2, which is 62F. Why that is the case? Because these two are different objects and they are stored in different memory locations. So this particular function or method should know on which object I'm calculating the order price for. So that's why it needs the address of cust1 and cust2. So self would basically be pointing to DE2, which is the address of cust1, and next time when we execute calculate order price, this time self would contain the value 62F. So now that method or that definition, calculate order price, or that function rather, would work with the individual objects that are stored in DE2 and 62F, which are different memory addresses. So that is the whole purpose of self, that it basically receives the address of the variable which are created using the class. And it is true for string also, integer also, float also, list, but we do not see or use it because that is hidden from us as it is handled by Python automatically. But when we create and use our own class, we have to pass it. And it can be proven also by using the type of cust1 and type on self, and then using the id function on cust1 and id function on self. So every time it will match. The first time the address of cust1 will match with self and the type of cust1 would also match with self. So this execution would be done and it would be gone, and the second time it would match with cust2 because we are passing a different object. So let's see that. So I have these two objects created, cust1 customers and cust2 customers. So now what will I do? I already have id of cust1 created, and what will I do? I'll print the id of self also, and let me print cust_1 and cust_2 so that we can keep track. But before doing that, I'll have to use that particular function lot.calculate discount, and I'll pass the amount, which would be, let's say, 100, and that's it. Similarly, I'll have to execute it for the second object also, and this time I'll pass a different value, which is 200. Of course, it is not doing anything. We'll improvise the function definition and the method definition later on, but here I want to show you that every time it's the self gets the address of the individual objects. So first time what would happen, for cust1 the id of cust1 would be same as id of self, and for the second one id of cust2 would be same as id of self. And let me print type also so that you understand what class these variables belong to. Same is the case with self also. So let me execute this, and now okay, let's see from the beginning. So it is for cust1 and this is for cust2. So from here to here it is cust1. Okay, so first it will print the type of customer1. Basically it's an object of class customers. Then it is printing the address location of the variable cust_1, which is 44279 whatever. This is the address location, and actually this should be before this, and let me change it and then execute again. All right, so now it would make sense. So it is for cust1. The type of cust1 is, it's a variable or an object of class customers, and the address location is 4468 ends with 7904. Then I'm calling this method or the function, so it will go to the function, and here I'm passing the amount. So amount is actually 100, so I can print amount here also. So let me print the amount. Okay, so this is printing type of customer1 again. So it is an object of type customers. Then the address location, which is 6160, I'm calling the functions with this argument. So amount would get that argument. What did self get? Self got the address and the type of cust ID because I'm calling this method using the cust1 object. So self would contain the address location of cust1. So as you can see here, amount has been printed, and after that it is an object of class customers. And if you see, the address location is exactly same as that of cust_1. So the first time the self pointed to the address location of the variable cust_1. We can call it as a variable also, or we can call it as a object also. Now second time I printed customer2. Now, customer2 is an object or a variable of class customers. So I have printed customer2. What is type of cust2? It is basically an object of class customers. And then what is the address location? Something that ends with 5968. Then I'm calling the method or the function in the class, and I'm passing the amount, and I'm using cust_2 dot the definition of the method or the method name or the function name. So in the self, again it is going to the method calculate discount. Self would contain the same thing that cust_2 contains this time, because I'm calling the method or calling the function using cust_2 variable or cust_2 object. So that's why the amount would be 200 this time, and the type is same as cust_2, which is an object of class customers, and the memory location is also same, which ends with 5968. So this one and this one are similar. So that's what self contains. Every time you execute this method or function using different objects or different variables, and whenever you execute this, you have to mention self, or self is, if you are using id, then self would come automatically along with the other arguments, and self would contain the address of the object that you are calling the method with. So first time we're calling the method calculate discount with the object cust_1. So that's why self would contain the address location of cust_1. Second time I'm calling the function or the method using the object cust_2. So the address of cust_2 would be passed to self. So that's what self is. So in a nutshell, self contains the identity of the instance of a class, which is the object. Self contains the identity of the object, which is nothing but the address location of that object or variable, whatever you want to call it. Cust1 is an object or a variable of class customers. Cust2 is also an object or variable of class customers. So whenever we call any method, every time we are passing the identity of cust_1, which is the address of the memory location DE2, and self would contain the address of the memory location. DE2 would be passed to self for cust1, and 62F would be passed to self for cust2. And when you used functions like string, append, string low, etc., using the variable, we did the same thing. We did not do anything. Python did the same thing in the backend. Alright, so that's about self. I would request, if you have not understood this, please go through the video again and then only proceed. So just to reiterate, we define a class is a template, and we create variables or objects using the class. So cust_1 is an object of customers class. Cust_2 is also an object of customers class, or they can be called as variables of customers class. Now first time we are calling the method using cust_1. So it is passing the address of cust_1 in self automatically. Now as these are objects or variables, it would contain the address location where this is stored. So it's a pointer to the memory location. Same is the case with cust_2 also. It is a pointer to the memory location where this object is saved. Now whenever you call any method, that pointer is passed in the self variable. And it is true for the other function also. So if we execute cust_1 dot get customer details, the same address would be passed here also. Okay, so let me show you that as well. So I'll define the method customer underscore details, and see, self is automatically taken. I do not have to type it. And let's say I pass the customer underscore ID, and here I print the customer ID and the type self and ID of self. So it will be customer underscore ID, and I'll use customer underscore ID. So let me do it one by one this time. So I'll just use cust underscore one dot customer details, and I'll pass the customer ID, maybe 1 2 3 4 5. Now if I execute, so as you can see what it is printing, first it is printing cust1, then the type of cust1, which is an object of class customers, then the address location of cust1, which ends with 8096. Then I'm calling these two functions with 100 and 1 2 3 4 5. Now first I'm calling the function calculate discount, and calculate discount I'm passing with amount 100, so that's why it is printing. Then the type of self, which is an object of class customers, and the ID of self, which is the same memory address that cust underscore ID cust underscore 1 has. Now I'm calling the other function cust underscore details, and I'm passing the value 1 2 3 4 5, and it is going to cust underscore details. It is printing the customer ID, which is 1 2 3 4 5, and the type of self is exactly same as that of cust1, because I'm calling the method using the cust1 object itself, or cust1 variable itself. And the ID is basically the address location, which is same as cust underscore 1, and that's what self is. And I can do the same for cust underscore 2 also, and the output would be similar. So now if I execute, I would get the same thing, cust2 object of class customers 1392, amount is different 200, the type of self, the address location of self, then I'm passing customer ID 2208, calling customer details, type of self, and address location of self. This is different, there might be some problem. Okay, I use cust underscore 1, so that's why it is showing different. But if I execute again, cust2 self is also the pointer to the memory location of the variable cust underscore 2. So that's what self is. That's what self contains, the pointer or the address location where that variable or the object is stored.